All right. Good morning, everyone. Welcome to another session of Splunk Mumbai user group. I hope you guys are doing great. Before starting into the topic, let's see what we have over here. You guys can connect with us on Slack channel. So it will be helpful for us for question answer during the session. Also, you guys can mute yourself if you're not speaking. And the slides, recording, and feedback form, all those things you will able to find out on the event page after the session. So today's topic is Splunk Observability. There are certain guidelines, which you need to follow. Also, if you guys have not registered for this event, please do it right now. All right. So let's see what we have for today's agenda. So we will gonna try to understand what is Splunk Observability. We will gonna see what are the products we have for the Splunk Observability. We will understand, how we can connect AWS with Splunk Observability. Oh, all right. It's me. So my name is Vikram Yadav. I do have more than 3 years of experience in Splunk. I work as a Splunk admin and developer at Avotrix. All right. So now we are starting with the topic. What is Splunk Observability? So observability is a quality of a software, or I can say a service, which helps us to understand how our system is behaving. Okay, let's say if we have something, let's say if something happens unexpected to our system, with Splunk Observability, we can quickly troubleshoot the problem and we can fix it. Splunk Observability gives you the most recent view of your system, of your application, and also your business matrices. Now, what are the key components we have in Splunk Observability? We have a matrix, we have a traces, and then we have a logs. So let's start with the matrix. So in the matrix, to detect what is happening or what is wrong, we use the matrix. Second, we have a traces. So to troubleshoot or to find where is it happening, we have a traces. And the last, we have a logs over here. So with the logs, we will able to understand why is it happening. So these are the three main components which we have in the Splunk Observability. And next, what we have? Now is the time to understand what is the difference between the monitoring and observability. So monitoring is a way, to analyze and to understand the data about the health performance of your system. Like, you are keeping an eye on those things that it can go wrong. In monitoring, we have resource information like your application, how your application is acting, your CPU utilization, or how fast your network is responding. So all those things we have in the monitoring. Whereas if I talk about the observability, so if something happens unexpected to your system, and then we need something so that we can quickly troubleshoot and fix that issue. And that's where Splunk's observability comes into the picture. Observability brings the whole new data to enhance the monitoring. Now we can look entire environment. We can bring the data from Kubernetes or from containers inside the Splunk observability. So before going further, do you guys have any questions to here?
No.
Okay, I got one question from Satpal
Vikram,
Singh.
I believe your voice
Uh,
quality
so,
is not good.
uh,
Or is it just
okay,
for me?
let me. Is it for everyone or is it only for Ashish?
For me as well. So
I think it's for me also. It's breaking your voice.
Okay, let me check my internet. Give me a second. Now it's better than before.
Yeah.
It's better.
All right. Thanks. I do got one question from Sapal Singh. He's asking, what is trace? So basically, we use trace to troubleshoot to find where it is happening. Now, let's say if you've got some issues in your server, right? So we need something to find out like, where all those issues are coming from. So far, we have a traces. I hope I have answered your question, Sapal Singh. Yeah, thanks. Let's move further. After the monitoring and observability, next we have over here the products. So in products, we have Splunk infrastructure monitoring, we have Splunk APM, we have Splunk RUM, and then we have Splunk on-call, and in the last we have Splunk log observer. Before discussing all these products, does anyone knows what was the formal name of Splunk infrastructure monitoring? And what was the former name of Splunk APM and Splunk on-call? Anyone is aware? All right. Let me tell you. So Splunk infrastructure monitoring, before it was known as a Signal FX infrastructure monitoring. Splunk APM, before it was known as a Signal FX microservices APM. And Splunk on-call, before it was known as a Vector Ops. All right. So let's start with the Splunk infrastructure monitoring. So, with Splunk infrastructure monitoring, we can monitor entire on-premise infrastructure. We can monitor our VMware environment. We can get the data from public clouds like AWS, Google. We can also monitor Kubernetes and container with the help of Splunk infrastructure monitoring. Next, we have Splunk APM, which is also known as the application performance monitoring. APM is all about traces. With your code, within your code, you have a traces that are going to tell you what's happening within your application, what steps are taken in that application, how long different steps are taken, and so on. Okay, so all these things we will be able to come to know by using Splunk APM. Next, we have Splunk RUM. It is also known as a real user monitoring. Okay, so it also has the same concept. Let's say, within your application, we have a traces that will report back, what is happening within your application. So Splunk takes that information, and helps the developer to understand and optimize the user behavior, or we can say a user journey. After that, let's talk about the Splunk Observer. So it allows us to review the associated log within the matrix and traces. And if I talk about the Splunk on-call, so, for effective alerting, we have Splunk on-call. You can integrate Splunk on-call with Jira, Okta, and Microsoft Teams. So this was the overview of the Splunk Observability product. Before going further, anyone has any questions to here? All right, perfect. Let's go ahead. Now, what we have in the next slide. Okay, now we will gonna see what are the different ways we can configure the AWS connection. So almost, we have three ways to configure the AWS connection. First, we have AWS Integration Wizard. Second, we have Splunk Observability Cloud API. And the third, we have Splunk Terraform. Anyone knows what is Terraform? Anyone is aware? All right. Let me tell you. Basically, Terraform is a tool that is used to manage the thousands of cloud services. Okay. So with Terraform, you can manage the entire life cycle of your infrastructure. We can only use Terraform, like when we are already managing our infrastructure with Splunk Terraform. That was the overview of the Splunk Terraform. Next, we have a Splunk Observability Cloud API. So as the name suggests, we have an API over here. It means what we have to use multiple methods. So to get our data, to fetch the data, so we will gonna use post and put method to get the data from AWS to Splunk Observability. And the last method, we have AWS integration wizard. So we're gonna this method discuss in coming slide. Let's try to understand, what is the workflow, how it will gonna work to get the data in Splunk infrastructure monitoring. So here you can see we have a cloud services. Let's say, in the cloud services, we have a AWS, okay? So in AWS, we have our infrastructure. Now what we want over here is, from the AWS cloud, we wanted to fetch the data to the Splunk Observability. So we will gonna use AWS integration method to collect the logs from AWS to Splunk Observability. And once we have the data inside the Splunk Observability, we can troubleshoot and fix the issues. Okay, so this is how it will gonna work. Now you guys might be wondering, what are the requirements we need to make a connection between the AWS and the Splunk Observability? So we only need admin rights in the Splunk Observability as well as in AWS. Okay, before going further, do you guys have any questions to hear? Okay, perfect. Now let's try to see, how we can get the Splunk Observability trial version. So for the Splunk Observability, we don't have to download any kind of a software. Everything is hosted on a cloud. Okay, so we get a trial version for 14 days. Let's see how we can get the trial version. So we have to click on this link, copy link, and I will go to my browser. Okay, so over here you can see we are able to see this UI. From here, you have to select your region, let's say US, and then click on next. Here you have to fill your details like your email, first and last name, and so on, and then you will able to create an account over here. After that, you will receive an email. Okay, so in that email, you will able to find out the details to connect to the. You will able to get the details of Splunk Observability, and this will be your URL. Okay, and you have to use the same email address and password over here to access the Splunk Observability. So the UI, what you can see over here, this UI is the UI of the Splunk Observability. Okay. Now, let's try to see the live demo, how we can connect AWS with Splunk Observability. Over here, you have to click on this menu. And then if you go down, here you can see the data setup. And in the data setup over here, you can see we do got a multiple options over here, right? So you can connect a multiple applications, services, and so on. So in this session, we're going to try to ingest the data from AWS. So I will go for AWS over here. And then you have to click on Add Connection. From here, you have to select your region. So if you're from China, you can select China. If you are using a government cloud, then you have to go for this government cloud. And if you are using a public cloud, that is for the AWS. So you can click on AWS region. In the authentication type, we have from two ways we can authenticate, whether external ID or with the security token. So in this session, we're gonna see how we can connect with security token, and then you can click on next. Now over here, you have got all the steps what we have to do over here. The very first thing what we have to do over here is we have to create a policy inside the AWS. If you can look over here, we do got a set of permissions over here. We have to, we have to enter all this permission inside the AWS account. So I can copy this and click over here. Now in this, you have to click on JSON, erase everything, and just do a paste. So over here, you can see, you are able to see the same thing. Okay. And then click on next. We are not adding any tags over here. So click on review. Here we have to give the name for the policy. Let's give a name. Let's write Splunk O underscore Mumbai. And then click on create policy. So here you can see we have created a policy over here by the name of Splunk O underscore Mumbai. Okay. So we have completed almost 40% of our job. After this, what is next we have? Second thing, what we have to do over here is, we have to sort of connect with the Splunk Observability. We have to attach a user to this policy. So click on this link. Okay. So over here, you have to create a user. So click on the add user. Here we can give the name for the user. Okay. So let's say Mumbai underscore user. Now you have to check this box, access key. Because we need an ID and we need a secret key from AWS so that we can enter that ID and secret key in the Splunk O. So make sure to check this box and then click on next. Over here, we have to attach that policy which we have created in the previous step. So click on attach policies. Over here, you have to search for your policy name. Splunk O underscore Mumbai. Check this box and then click on next. Click on review and then simply click on create user. This will be your last step. Okay. So over here you can see I have got an ID and I have got a secret key over here. Now these two are very much important. Let me go back to my Splunk O. You can click on next over here. Here you have to enter that ID which you have got from AWS. So I will copy this ID and I will simply paste over here. Here you have to enter your secret key. Here I have my secret key. Copy and paste over here. Access token will be our default and then click on next. So over here you can see we have successfully made a connection with AWS. Now from here you can select at what interval CloudWatch should pull the data from AWS. So I'm keeping as a 300 seconds. From which reasons you wanted to pull the data, that you have to select. So for now I'm just trying to pull the data from all the regions which I have in my AWS account. And then click on next. So over here you can see we have successfully made a connection. And now we can see our data in Splunk Observability. Now, before going further, anyone have any questions to here?
Yeah, hi Bikram, can you hear me?
Yes, I can hear you.
Okay. So can you show us or share us the JSON POs for creating the policy?
Yep, definitely. You will able to get a recording of this video on the homepage of the Splunk Mumbai user group, and from there, like you can refer the steps again.
Okay,
Yeah.
thanks.
Thanks. Yep, thank you. All right, guys, let's proceed further. Now, if I click on infrastructure, here we are able to see two services, EBS and EC2. So before going further, let me tell you what is EBS and EC2. Let me give some basic idea over here. Now let me close this. Okay. So over here you can see I have a EC2 instance. So EC2 is powered by virtual services, which we are calling as an instance over here. And each instance has a Amazon machine image, or I can say a AMI. So each Amazon machine image can have more than one Amazon Elastic Block storage that we can call as a EBS. So over here you can see we have a EBS storage. Okay. Now let me go to the EBS. Here you can see I'm able to see the results. So I have two instances on my account. Those two instances I'm able to see over here. For that volume, I'm able to see over here. How many volumes we have in our account? We have two volumes that we are able to see over here. Here you can see I'm able to see some chart. So here, if you look properly, we have volume write ops. Now, what is volume write ops? So volume write ops is nothing but it's a total number of a write operation. OPS is nothing but the operation. So here I'm able to see total number of a write operation. And if I go further, you're able to see volume read ops. So volume read ops is nothing but total read operation. Okay. From this also, if you look over here, red line refers to the read, and whereas blue line refers as a write. And if I go to the next chart over here, you can see I do have a multiple things over here. Same way, volume write byte. Volume write byte gives the whole write information. It provides the right information. Same goes for the red one, that is the read bytes. It provides you the read operation. If I go scroll down, here I'm able to see the read operations, at what interval I am getting those operations. Here I'm getting via read wise, and here I'm getting via bytes wise. Next, we have a write operation. In this, we are able to see a multiple percentile distribution, like we have P90 over here, and then we have a minimum over here. Okay, so at what time we have got all this percentile, we are able to see over here. Also, we have a latency over here. At what time, you have got that latency also the read one that we are able to see over here. So, we don't have to create any of these dashboards over here. All these things, which have got over here that are pre-built. We have not created anything from here. Now, in this visualization, you are able to see the data from both the instance. Now, if you only wanted to see the data from only one instance, so from here, you can do a filter by your instance ID. And depending upon that, you will able to see your results. Okay. After this, let's see what we have in EC2. Here you can see I have two instances, ID number 11E and ID number 175C. Same thing you will able to see over here, 11E and 75C. How many active hosts you have in your AWS 2? what are the regions for that host that we are able to see over here? So both the hosts have a same region. From here, you can verify. And if I go down, from here you will able to see percentage-wise distribution for the CPU users. The best thing about this over here is you will able to see the what was the percentage used by P90, maximum, minimum, P10, and medium. What's the topmost host you have in your AWS account that you are able to see over here. Top mean by what is the top percentage CPU utilization by the mean wise, that also you are able to see over here. Next, after this, over here you are able to see the memory wise utilization. Okay, same goes over here. We do have a network wise visualization. How many network bytes came inside your into your AWS account, and how your network is flowing. That we are able to see over here. Okay. So that is what we have over here. Do you guys have any questions? Anyone?
Yes, Bikram, I do have one.
Yes.
So, what about like the chargeback model for this Splunk observability?
Chargeback model. What do you mean by that? Like chargeback model?
Pricing, for example, generally Splunk charges on the basis of indexing capacity. So
Right.
here, when we are like opting for Splunk observability as a monitoring or observability solution, then in that case, the billing model will be like how will be billed?
Okay. So over here, the billing model we have via the host wise. Depending upon your host, your billing model is made. So hire the host, depending upon that, you have to charge. We are not charging how much data you are trying to ingest over here. It's
Mhm.
it's depending how much host you are trying to connect with the Splunk observability.
Okay, fair enough.
Yeah.
Second, a second query with regards to, so currently we are able to see some server-based computes, like EC2 is server-based compute. When we'll turn
Right.
towards serverless compute like ECS and or any such like Kubernetes service we can say. So in that case, will it be able to like get all those details or all those telemetric as well as application performance metrics?
Uh, yeah. See, that is also is possible. You can get the data from a Kubernetes or container. So at that scenario, we have to use a different. We have to follow a different procedure. For that, we have to use Open Telemetry to collect the logs from your Windows instance, or I can say Kubernetes.
Okay.
Yep.
I'm still, a little confused. For example, here the IO and all those stuff to be tracked from a server-based compute like EC2 is quite we can understand it's logical. When we talk about ECS computes, it's like completely serverless, and then getting information which is exposed to somewhere on a port or somewhere like it's been open to be scrapped by any other application. That what like Splunk observability is doing in the background. That what I like understand at this point of time. Being unknown to this, this thing. So
Yep.
I'm little curious, to understand.
Um, I think I can
Okay.
answer that question for you. So what happens is your understanding is correct, right? On the back end, what is happening is there's a bytecode injection. That's BCI is what is called. So let's say
Mhm.
you want to monitor, something which is orchestrated, like let's say Docker, Kubernetes, or EKS or so, which are basically serverless because they are running on a containerized platform. So what happens is when you have the open telemetry agent, right? That
Mhm.
agent injects a bytecode into the process itself. So let's say, for example, Splunk, right? Splunk
Mhm.
D is a process. So the agent injects BCI into Splunk D process itself. So whatever that process is doing, that like let's say that process talks to five other process or sub processes or threads, that kind of information can be directly fetched. And hence, I think in the Kubernetes world, it needs Vagrant or I think not Vagrant or Helm chart. It utilizes a Helm chart to get the data. So it basically injects a separate container which monitors the whole EKS or the Kubernetes environment and gets the data out of it. Does that answer your question?
Yeah, at extent, but I'll tell you a use case where I'm looking forward to, the get input. For example, recently I deployed Kafka using ECS service of Amazon, and there,
Mhm.
like since Kafka put its telemetric information or its, observability metrics on certain port, right? So I
Right.
simply looked upon it that how I can get those metrics on like either of the like observability platform. So this looks like very fine. So if I'm looking to get all those performance metrics from Kafka, which is exposed to a certain port, how will gonna like how I'll achieve that? Since I'm using ALB as well. So at the front end, what I'm having is just a ALB. So using that, I won't be able to like look up onto a particular port. That's the issue. And then in that case, how will I, like, trace that information?
So, in this scenario, what I understand is since you are using ELB and the port numbers would not be directly accessible, then I think Vikram was talking about two, three different ways by which we can get the data. So, is there no possibility that you can access the data via API? API is one of the another mechanism. So, let's say if we can, rather than listening the data, Splunk goes and pulls out the data via REST calls. It does a REST API every 1 minute, 2 minute, gets the data and then work on it. Is there no possibility of that sort available with Kafka?
I'm not familiar much with the REST, like or API designing. So
Mm-hmm.
I can't comment on that part, or I can say like I don't have right answer for that. I
See,
can see.
even I haven't got a chance to work on the Kafka side. That's the reason I do not know the exact way how would we would get the data. But there are two things, right?
Mhm.
So one is I can listen the data, and the another is I can fetch the data. So listening also, if you see that there is a problem of ELB and then ELB we are not directly able to access the data, then there is another option called as Kinesis Firehose. What you can do is you can forward the data to Kinesis Firehose, and from Kinesis Firehose you can fetch the data to Splunk. There could be one of this possibility. I'm just, thinking theoretical way. I haven't implemented something of this sort, but Kinesis Firehose plays a very vital role of getting the streaming data. So Kafka is sending us streaming data, and Kinesis Firehose can help on that side. Let's say if that option is not a valid option or not an helpful option, then the second one is looking at, polling that data. I can poll the data via REST or something. This is, I'm just thinking very high level and addressing your problem.
Yeah, I understand. So when we say that getting it through Firehouse Kinesis, again, that is something working on the log side itself. And those information, telemetric information about Kafka is not, getting logged. The very first thing, the very first issue. Second thing, when we say that we will use some API call to listen out those metrics, that's the issue. When we talk about like serverless compute, we are actually exposed to a ALB only. And using that ALB, it's really difficult to listen something or like pull something which is exposed to a particular port.
Uh, we'll have to look into this current situation where ELB is coming into picture. But so when you are using ELB, This is basically a software load balancing or hardware load balancing.
Okay, I'll tell you. Whenever we are like using container service of Amazon, that is ECS. So in
Yeah,
that case,
EKS or ECS.
ECS,
Okay.
Elastic Container Services. So whenever
Okay.
we are using that, in that case, since it's a serverless compute, right? So in serverless compute, you definitely gonna like not get directly like exposed to the compute which is like you use at the other end. That what like it like been configured for. So
No,
in
I,
that case,
I
what
understand what you're
Amazon do
saying.
provide,
So that
it
is one part of it, right? So what you're doing is basically what Amazon is doing is it is containerizing it and
correct,
putting a wrapper over it and giving it to you, right?
correct.
Now, let's say on the back end, right? Obviously, we do not have access to the back end here. Like, what is the node, what is the master, which are the worker nodes and all. We don't have access to on the back end, right? We only are exposed to the front end because there's a wrapper running, and that wrapper, I believe in your case, is ELB, right? So now, let's say I do not know what is running on the back end. Can't I run a container which is behind the ELB, right? Because see, I have five different containers running. I spin up another container, and
Hmm.
that container actually monitors all other containers and sends the data. Is that not possible?
Come again. I actually didn't get it
Okay,
quite
let me
again.
let me tell you. Yeah, so this is something which we are doing with OpenShift here in on premises.
Mm-hmm.
So you have a containers, right? Okay.
Mm-hmm.
So I have 10 containers which are running. In along that 10 container, I spin up another container, which is the new container which I'm talking about,
Mm-hmm.
would be spinned up by, an automation. Maybe, we are using some Helm chart, which has a specific configuration to go ahead and, start monitoring that specific port.
Mm-hmm.
Okay. Now, what you have done is instead of monitoring that specific port outside, which is being blocked because of ELB thing, I am monitoring that port inside the container itself and spinning it up as a service. And then I can do a REST call or a web service or an send via HEC. So what I'm trying to say is the data, rather than I'm fetching the data outside, I'll fetch the data inside itself, and I'll do a Python. I'll write a Python which will fetch the data from that specific port within the container itself and send the data via HEC or something. Is that a viable option?
Uh, I'm again not sure because like how we can go and use the same you know uh, container where your one of the compute is like one of your application is working. I'm not sure that it will gonna like interact, but as a service we can configure that seems to be little viable, and I think I need to
This is the same
check.
thing. Sorry to cut you down. This is the same thing which we are doing in our on-premises OpenShift Kubernetes cluster. So what we are doing is, let's say you have three clusters. In each of the clusters, right, there would be a container which would be spin up. Obviously, it is not monitoring a port. It is monitoring some different services logs, which is coming via telemetry, and that data it is sending to via HEC. So basically, it's a service within a container itself, which looks at the data which we are looking for and sends the data via HEC. So see, I am just thinking aloud, that whether this can solve your problem. I'm not very sure. There could be 10 other limitations which I have not thought about, but you could think on this lines and see if that can address your problem.
Yeah, definitely. And I guess like I have already taken a lot of time. Yeah,
Yeah, sorry.
I'll give a try on it. But there is one more area which is I'm observing, which is gonna like be a blocker. Because in case of like Kubernetes pods, we generally have our defined cluster. And when we talk about Amazon ECS, Amazon Container Service, we do not have a defined, like I'll say, a cluster. So that could
Right.
be a blocker. But that again, I need to check on. Okay, thanks Ashish and Vikram. I guess we need to move if someone else, like, looking forward to you people. Thanks for, input.
Thanks, Ashish, for answering that. Anyone else have any other questions? All right. Thank you so much, guys, for joining our session. You will get the recordings and feedback from after the session. Okay. Thank you so much, guys. Bye bye.
Yep. Thank you. Thank you.
Thank you.